All right, Prop 23 says, on a given straight line and at a point on it to construct a rectilineal angle equal to a given rectilineal angle. So in other words, this is the proposition that says, yeah, you are legally now allowed to copy-paste angles. But, there's a construction involved and some precision involved, so let's jump straight into it. So we'll assume that this is our angle, angle C. And we want to recreate this angle right here at point A. So here's my line AB, and I want to construct this angle C off of point A. So how do we do it? Well, first of all, on our original angle, we're going to grab 2 points on either of the straight lines, call them D and call them E, and they can be anywhere. It doesn't matter. So, right, I guess I should write that out as part of the construction. So, how should I say? Choose points D, and this is probably kind of loose and not as precise as I want it to be. Choose points D and E on angle C, and then connect DE. So, not the most precise language, but I think you understand what I mean. Just to choose 2 points, and obviously those points should be on opposite sides, opposite lines in this angle. We don't want to choose D and E on the same line. So choose D and E and then connect them. Okie dokie. Well, now that we've done that, can you guess where we can go with this? Hint, hint, our last proposition was basically, hey, if you have 3 straight lines or 3 lines that can make a triangle, then here's how we can recreate that triangle, recreate those exact same lines, but on a different line. And that's basically what we're going to do. So we're going to use proposition 22. What does Euclid say? He says, and out of the 3 straight lines which are equal to the 3 straight lines CD, DE, CE, let the triangle AFG be constructed in such a way that CD is equal to AF, CE is equal to AG, and DE is equal to FG. So, let's see, and does he... Right... Just want to look at what he says. Yeah, he specifically says create the triangle. So he's not just saying copy those down onto AB. He's kind of like doing all of Prop 22 in one, where he's saying copy these down onto AB and create the triangle that they form. So let's see here. We'll say, maybe I'll say construct, and I'll use the ordering of the letters that he uses. I need to be a little bit careful here. Construct triangle AFG such that, let's see, AFG, so I believe that AF is equal to CD. And you do need to be a little bit particular about this because we specifically want angle C. So I need to make sure that angle C is the one that's being created at A, not angle E or angle D. So that's why we need to be a little bit careful. So it should be the case that AF is equal to CD. And I'm just making sure, yeah, such that AF equals CD. AFG, so AFG, FG must be equal to DE. Is that right? I'm just making sure. Yeah. FG is equal to DE. And then lastly, it will be AFG that is equal to CE, right? Yep. And AG equal to CE. And all of this is made possible by Prop 22. We just proved that. Okay. Right, and the way that Prop 22 was, it was kind of like if you imagine taking C and putting it point A, and then taking CD and like kind of swinging it down this way, taking DE and swinging it down this way, so that there are three line segments. Like A would be kind of in the middle of the line segment. Like here's going to be one line segment. Then there's A, I guess it's AG, and then the GF will be over here. In any case, I'm just going to kind of shorthand it. So here is CD. So the way that I'll do this is I'll just make this little semicircle right here. I know it's faint. And CE is going to lie on AB. So right there I can say this is G. And then lastly, ED, which is going to come off of G. And where the two circles intersect is going to be the third point of the triangle, connecting A and G. So this will be point F up here. And all of this was just Prop 22. Like all of those steps, that's literally just contained in Prop 22. So this is F up here. All right, well then, I would say by construction, right, and here's where I want to be a little bit careful. Triangle, let's see, so I'll call it maybe AGF is equal to CED. So triangle CED equals triangle AGF. You maybe can see why I need to be a little bit careful with the lettering here in my textbook. They are not careful with the lettering, which is, fine. But it's just in big bold letters. Right. Then, so this is by construction, and this is just side, side, side. By construction, the side lengths of each of these triangles are the same. So that's by proposition 8. That gives us side, side, side. And that's it. Because since these two triangles are the same, in particular, we have that triangle or angle GAF equals angle ECD. So, angle GAF equals angle ECD as required. And Prop 8 gives us exactly that. I guess technically, I guess this is not completely the proper way. This is kind of like a modern shorthand, because remember, Proposition 8 is the one that basically says, really what Proposition 8 is saying is that because CD equals AF, and because CE equals AG, and because DE equals FG, we have that these angles are the same. So Prop 8 doesn't actually say that the triangles are the same. Prop 8 in conjunction with Prop 4 says the triangles are the same. So that's kind of why I'm just shorthanding it rather than writing out all of Prop 8, all of that for Prop 8, because the conclusion is the same. Right, and that is exactly what we needed. So yeah, and if you look at these, I mean, it's the exact same triangle. Definitely those angles look pretty much the same to me. So that's what we needed. QEF.